Welcome again, our viewers. Let's try to focus on the part of how we are supposed to do a simple calculation whereby we are trying to follow the principles that we know. The principles of assigning the signs, the principles of putting the directions of currents, and the principles of how each and every loop is going to behave. All right. Now, in this case, let's try to, you can move in this, you can move in whichever direction you want. What do I mean by that? Here, if we're trying to get the direction we are going to take, we can either move clockwise or in anti-clockwise direction. So what are we going to do? Let me try to move in clockwise direction. I'll go in this given direction. Here, if you want, you can move in clockwise direction. If not, you can move in anti-clockwise direction. It's not a forcing matter whereby you're supposed to move in anti-clockwise direction. So the word if we move, we are trying to mean something like the direction you are taking. In this case, we are taking the direction which is a clockwise direction. There we are moving in the anti-clockwise direction. The previous video we were explaining about the issue of if you move in the same direction as the current across a resistor, automatically the voltage on that same resistor has to be 0. Then the voltage across the other one, if you move in the opposite direction with the current, it has to be positive. Sorry, if you move in the same direction as the current across this given resistor, its voltage has to be equal to negative. Then if you move in the opposite direction to the current across that same resistor, then the voltage has to be positive. That's what we explained in the previous video. Now here, let's try to check properly what will be the voltage across this, what will be the voltage across that, what will be the voltage across this, and also across this if we pick this given loop. Wow, I'll just try to handle this same loop, then this given loop, it has to be yours. Thank you. Let's try to proceed now. Remember, we are moving in this given direction. So here, if you pick this given direction, what you notice is across that given voltage source, we are moving from negative to positive. That simply means the voltage across this given voltage source, based on the points I just gave you in the previous video, this has to be a positive voltage. There's a rise in voltage. Why? Because we are moving from negative to the positive. We are increasing in the voltage across this given resistor. If you come here, remember, we are encountering the positive part first, then we come to the negative. So there's a drop in voltage. And in this case, based on the points on the previous video, we said if you're moving in the same direction as the current, automatically voltage across that same resistor has to be 0. This is the thing that we were talking about. So since we are moving in the same direction as the current, if you move in clockwise direction, you are encountering the positive first, then negative, of which you are dropping in the voltage. So here we are going to have a negative voltage across this. If you come here, what you notice is we are moving in the same direction as well as the current. When you move, you keep on moving until you come here. You also go in this given direction because we are using a clockwise manner. So we are moving from positive to negative. Let's hope you remember how to assign these charges. So we are moving from positive to negative. The voltage across this given resistor is dropping. So we need to have a negative voltage at this given point. Why are we having a negative voltage at that given point? Because we are encountering the positive first, then we come to the negative. Same applies even to this. Remember, we are moving in the opposite direction to the current the voltage source can produce. So we are encountering the positive first, then we come to the negative. There will be a drop in voltage across this given resistor, and its voltage has to be negative. That's what the voltage law of Kirchhoff is trying to explain to us. So let's try to have this part. You can try to assign, or you can try to come up with the voltages across each and every element. So here we have a negative voltage because if you move in clockwise direction, you are encountering positive first, then negative. If you move in this direction, you are encountering positive first, then negative. Same applies, positive, negative. Only this part, that's where we have some changes whereby we encounter negative first, then we come to positive. There's a rise in voltage from negative to positive. There's a drop in voltage. there is a drop in voltage, there is a drop in voltage. Can you try to assign or come up with the voltages for each and every element based on this same loop as we are proceeding to the next? That's your duty. Bye bye.